Okay, so we're still going to use this quotient property, but we've got more parts to it now. So we're going to look at that 80 and think, well, what times what is 80? So I think 16 times 5 is 80, if I remember right. And then I've got an m cubed, and I've got an n over n to the 6th. And it's not going to simplify. I would always try to simplify the rational expression first if you can, but nothing simplifies here. Okay, so it's a square root. Square root, you have to worry about absolute value. So I'm going to make you a little list of rules here, because absolute value, if that's the only thing tripping you up, you only worry about it if it's an even root. If it's an odd root, you don't have to worry about it at all. And then, so that's step 1, look at that. And then step 2, when it comes out, so when it's out, if it has an odd exponent, then you need the absolute value. Okay? All right, so square root of 16 we know is 4. The m, we have 3 of them. One's going to come out, but because I only have 1, I'll have to put the absolute value on it. And then what's left in the numerator is just a 5 and an m inside the radical, inside the square root. In the denominator, I have n to the 6th, so I've got 3 groups of 2, so I'm going to take out n cubed, and I'll have to put absolute value because n has an odd exponent, okay? And there we go. So the next one, don't worry about absolute value because it's an odd root, so no absolute value here, because odd root. Okay, so what's 108? Let's see, what goes into 108? I don't know. So I'm going to go over here and I'm going to make a chart for me. 2 times 54, and then 54, if I remember right, is 2 times 27. Okay, that's a perfect cube. So it takes me a minute, but I found it. So I have the cubed root of 27. And then I've got c to the 10th. So I'll just write c to the 10th. Oh, darn it. I didn't write the 4. We got to write the 4. Okay, so what do I mean by the 4? That right there. You can't ignore that. So sorry about that. 4 times 27 times c to the 10th over d to the 6th. Okay, so we're going to take out the 27 because that we can take the cubed root of. So there's the 3. And then I'm thinking about c to the 10th. Well, that's 3 groups of 3. So I have a c cubed on the outside. And on the inside, it's a cubed root. I have a 4, and I have a leftover c. And then in the denominator, I'm just going to have d squared. Now remember, we don't have to worry about absolute value here because it was an odd root. So that one's done. And all those symbols matter. Okay, so 4th root, we do have to worry about absolute value. 680 is 16 times 5. I think we did that earlier. But this happens to be a 4th root, right? A perfect 4th root. Okay, so let's go over here and write stuff out. 4th root. So we're going to have 16 times 5x to the 10th over y to the 4th. All right. So the 4th root of 16 is 2. So that comes out. And now I'm thinking about x to the 10th. Well, that's like x squared, because that takes care of 8 of them. And then on the inside, I'm going to have the 4th root 5x squared. So think of your x to the 10th as like x to the 8th, and then it's the 4th root of that, so that's where we get the x squared. But then you have 2 more still in there, so that's why the x squared had to stay in the radical, this one. Okay? You don't have enough to get another group of 4 out. Now, I didn't talk about absolute value on the x squared. Do I need the absolute value? No, because it's an even power. So it's going to be positive no matter what. Over, and then the 4th root of y to the 4th. Well, that'll come out as a y. And I will need the absolute value, though, because that has an odd power. Okay? All right. So a little tricky with the absolute values.